Ever wondered how big data is managed and processed efficiently? The secret lies in a concept known as MapReduce. Originating from functional programming and the world of distributed computing, MapReduce is a programming model that allows for easy data processing across massive data sets. It's a key player in the realm of big data, handling and dissecting information at a scale that other models can't match. Now, where does Hadoop fit in all of this? Well, Hadoop is an open-source software framework that uses MapReduce to process and store large amounts of data. It's the superhero of big data, using its MapReduce power to defeat the villainous challenges of processing and managing big data. MapReduce and Hadoop together form a dynamic duo, making the daunting task of dealing with big data a walk in the park. Now that you have a basic understanding of what MapReduce is, let's dive deeper into its types and formats. In the world of Hadoop, MapReduce is divided into two main types, Classic and Yarn. Let's dive into these two types, shall we? First, we have Classic MapReduce, or as some may call it, MapReduce 1. This is the original framework designed to process large amounts of data across a distributed computing environment. It's simple and robust, able to handle failures and recover data effectively. But it's not without its shortcomings. The most notable limitation of Classic MapReduce is its scalability. It can only handle a certain number of nodes, which can be a problem when dealing with massive data sets. This limitation was a significant catalyst for the development of the second type of MapReduce, Yarn, also known as MapReduce 2. Yarn stands for yet another resource negotiator, and true to its name, it's a more flexible and efficient resource management system. It separates resource management from job scheduling, which allows for multiple applications to run simultaneously, each with its own job scheduler. This greatly enhances the scalability, making Yarn capable of processing even larger data sets than Classic MapReduce. In comparison, while Classic MapReduce is simpler and easier to use, Yarn offers more flexibility and scalability. It's a bit like choosing between a reliable old car and a shiny new sports car, each with its own advantages. These two types of MapReduce have their own strengths and weaknesses, but they both serve the same purpose: efficient data processing. Moving on, let's decode the formats used in MapReduce. These formats are of two types: input and output formats. Input formats define how data is read into your MapReduce job, while output formats dictate how the results are written after processing. The heart of MapReduce data processing lies in key-value pairs. When data is read into the system, it's split into chunks, each represented as a key-value pair. The key is the identifier, while the value holds the actual data. This is the input format. After processing, the data is written back in the form of key-value pairs too. This is the output format. The key-value pairs from the output of the reduce function are written into the output format, ready to be used for further processing or analysis. Now you might wonder, how does MapReduce handle different types of data like text, images, or even serialized objects? This is where the concept of serialization and deserialization comes in. Serialization is the process of converting structured data into a format that can be easily stored or transmitted, and deserialization is the reverse process. MapReduce uses this to handle diverse data types. Understanding these formats is crucial as they determine how your data is read, processed, and written. So mastering the art of working with them is key to becoming a MapReduce maestro. So, we've covered quite a bit about MapReduce types and formats in Hadoop. Let's quickly recap. We delved into the two main types of MapReduce, Classic and Yarn. Classic, the original model, is characterized by its simplicity and robustness. Yarn, on the other hand, introduced more flexibility and scalability, making it a preferred choice for many. We also unpacked the formats used in MapReduce, focusing on input and output formats. Input formats define how data is split and read, while output formats dictate how the results are written back into Hadoop distributed file system. Understanding these formats is critical in optimizing your data processing tasks. This journey through MapReduce types and formats is akin to learning a new language. It has its own syntax, rules, and nuances. Mastering it is key to leveraging the power of big data with Hadoop. With this knowledge, you're now better equipped to navigate the world of big data processing with Hadoop. Keep exploring and stay curious.